Good morning to all of you. Welcome back to Hospitality Engineering. Today we will see HVAC Module-2 Part-2 Chilled Water Plant. What is chilled water plant? Chilled water plant is a combination of the compressor, evaporator, condenser, expansion valve. As all these equipments are arranged on the one platform, and nearby primary pump, secondary pump and condenser pump are arranged in different platform and connected together through the pipeline. These setups all together arranged in plant room. If you want to say simply, the chilled water plant produce the chilled water for comfort cooling and for the various other purposes. Now, what are the cycle available in the chilled water plant? There are the three important cycle available in the chilled water plant. The first cycle is refrigerant cycle. The second cycle is cooling water circuit, and third one is chilled water circuit. We will see each cycle one by one. Refrigeration cycle. The refrigeration cycle is the fundamental thermodynamic basis for removing the heat from hotel guest room or any building area and rejecting it to the outdoor. The refrigeration cycle requires four basic components. The first one is compressor, which is heart of this system. Second is condenser. Third one is the expansion valve. That finally evaporator. You can see how the gas flow is moving from compressor, compresses high pressure, high temperature into the condenser, where the high pressure, high temperature gas condensed and high pressure liquid goes to the expansion valve. When the high pressure liquid passes through the expansion valve, the pressure is controlled and partially vapor and partially liquid refrigerant goes inside the evaporator, where it get evaporated. Then finally gas, low pressure, low temperature gas goes back to the compressor. Thus this cycle is continuing in the refrigeration cycle. The refrigeration cycle diagram shows the relationship of this component, as does the pressure enthalpy chart, also known as pH diagram. Now we will see the pH diagram. You can see x-axis enthalpy, y-axis pressure. We can start from the compressor. Now you see the compressor, it compresses high pressure and high temperatures. So what will happen? Heat will increase, then the temperature also will increase. Then it goes to the heat exchanger and condenser. Here the gas change into the liquid and maintaining the temperature same. Here you can see the gases goes inside, the condensing is happening. While condensing is happening, the temperature will reduce, but the gas convert into the liquid. The high pressure, high temperature liquid again goes through the expansion valve, where the pressure is reduced and partially vapor partially gas goes into the evaporator. So the cycle is continuing here. Now you can see the subcooling where the pressure and the temperature is below the saturated point, then saturation mixture and superheated gas. So you can see up to which region condensation happening and which region superheat is happening, and subcooling also you can able to see in this diagram. Cooling water circuit and chilled water circuit. Now we will see the cooling water circuit, which is a open circuit. It starts with there is a condenser pump. This condenser pump receives the water by gravity from the cooling tower patient. It forces into the condenser. From condenser, it take away the heat, and this heat goes to the cooling tower through the various nozzles. While the waters spray downward in cooling tower, air started to flow from bottom to the topward because the fan is arranged at the top. While this fan rotate, it try to pull the air. So the ambient air comes and passes towards the nozzle. While this ambient air passes inside the cooling tower, it crosses all the droplet that mixed with the air. Thus, adiabatic process is happening inside the cooling tower. Now, the wet bulb temperature, nearer to the wet bulb temperature, the water will reach. Once this water cooled by gravity, it comes back to the condenser water pump. Thus, the cycle is continuous. However, this is a open circuit. Chilled water is a closed circuit. In chilled water here, there is a chilled water pump. We can call it this as a primary pump. It forces the chilled water into the evaporator. From the evaporator, the water goes to the various user point like FCU, TFA, AHU, like all the user area through secondary zone. Then the water return back to the primary pump through the air vessels and filters. Thus here the chilled water circuit is a closed circuit. Now we will see refrigerant. What is a refrigerant? To address the safety and environmental concern, refrigerant must have the low toxicity, low flammability, and the long atmospheric life. Recently, refrigerant have come under increased scrutiny by scientific, environmental, and regulatory communities because of the environmental impacts attributed to their use. Now you can see which are the refrigerant phase wise. Now you can see which are the refrigerant going to be phased out by year wise. Chilled water, main plant equipments. So compressor, as I told you, it is a heart of the system. From the compressor, it goes to the condenser. From condenser, it comes to the receiver. From receiver, it goes to the expansion valve. From expansion valve, it goes to the evaporator. So we can divide into the evaporator side, low side, then the other side is the high side. Like we can able to divide these chilled water plant into two part, low side and high side. Compressor. As we said, compressor is the heart of the system. We will see what are the important type of compressor used in the packaged water chiller. Reciprocating. The picture is self-explanatory. The gas comes from here. There is an inlet port. While the piston move downward, the gas comes inside. Then while piston move upward, it get pressurized inside the cylinder. The gas got pressurized inside the cylinder by the piston. The delivery port open. Then the gas goes outside in the reciprocating. Whereas in the rotary, there is a rotary movement. So based on this movement, the gas enter inside and get compressed in the rotary compressor. In centrifugal, there are multiple impellers are there. It is similar to the centrifugal pump. Now we will see further reciprocating compressor in detail. In reciprocating compressor is a positive displacement compressor that uses the piston driven by a crankcase or crankshaft to deliver the gases at the high pressure. You can see here there is a section, there is a valve port, then there is a delivery and delivery valve port, while the here crankshaft, connecting rod, crosshead, then piston. So while piston is moving up and down, then while piston is compressing, the gas goes inside. This type of reciprocating compressors are mainly used in the oil refinery, gas pipeline, chemical plant, natural gas processing plant. Also, widely used in the refrigeration plant like cold room. Rotary compressor. There are four types of rotary compressor used in HVAC industry. They are scroll compressor, single blade or fixed vane compressor, rotating vane compressor, screw or helical rotary compressor. Now you can see in this picture there is an inlet where the gas enter, which is shown in the blue color. Then after the compressed gas, the hot air, high pressure, high temperature gas goes out in red color. The helical, both male and female gear is rotating inside. In packaged water chiller, the most commonly used compressor is the screw. There are two types used in today. One is single screw compressor, another one is multiple screw compressor. Single screw compressor. The single screw consists of the single cylindrical main rotor that works with a pair of gate rotors. The compressor is driven through the main rotor shaft and the gate rotors followed by direct meshing action, which you can show in the picture. As the main rotor turns, the teeth of the gate rotor the slides of the screw and the casing trap refrigerant. As rotation continues, the groove volume decreases and compression occurs. Single screw compressors are noted for long bearing life as the bearing loads are inherently balanced. The single screw has slide valves on each side that can be operated independently. This allows the machines to have a very low turn with good part load energy performance. Twin screw compressor. The twin screw is the most common type of multiple screw compressor. The twin screw is the common designation for double helical rotary screw compressor. The twin screw consists of two matching helically grooved rotors, one male and the other female. Either the male or female rotor can be driven. The other rotor either follows the driven rotor on a light oil film or is driven with synchronized timing gears. At the section side of the compressor, the gas fills a void between the male and female rotors, which you can see in the picture. As the rotors turns, the male and female rotor must and work with a casing to drop the gas. Continued rotation decreases the space between the lobes and the gas is compressed. The gas is discharged at the end of the rotor. The twin screw has a slide valve for capacity control located near the discharge side of the rotor, which bypasses a portion of the trapped gas back to the section side of the compressor. Centrifugal compressor. The centrifugal compressor is widely used in the large plant or large facility or large hotel. Centrifugal compressors are dynamic compression device as opposed to positive displacement. In centrifugal compressor, continuous basis exchange angular momentum between a rotating mechanical element and a steady flowing fluid like centrifugal pumps. It works. You can see there is a blow, the gas comes, then it gets compressed by the centrifugal action, and this red color hot gas goes into the condenser side. Now we will see the evaporator. In this picture, the liquid refrigerant at the bottom, it goes inside. So basically it will be partially vapor and partially liquid. It goes inside, then it completely becomes the gas. Finally, this gas refrigerant goes into the compressor. The other side, chilled water. For example, the inlet chilled water 12 degrees Celsius enter into the evaporator. Now it gets cooled by the liquid refrigerant. The other side, liquid refrigerant converting into the gas. Similarly, the 12 degree chilled water get cooled. It becomes the 6 degree, which is required for the supply chilled water, goes to the water outlet. This is a simple evaporator function. Now we will see what are the types of evaporators used in the water chiller. The flooded cell and tube, the direct expansion evaporator DX. These two types of evaporators are commonly used in the water chiller plant. Flooded cell and tube. You can see in the picture the flooded cell and tube, the water goes inside the tube, then the same water goes another side. So water goes inside and outside. The liquid means refrigerant. The refrigerant flows complete throughout the cell. So this type of heat exchanger is called flooded cell and tube evaporator. Now you can see there is some area where the gas get accumulated, then this gas goes to the compressor. The flooded cell and tube heat exchanger has the cooled fluid inside the tubes and the refrigerant on the cell side. The liquid refrigerant is uniformly distributed along the bottom of the heat exchanger over the full length. The tubes are partially submerged in the liquid. Eliminators are used as a means to assure uniform distribution of the vapor along the entire tube length and to prevent the violently boiling the liquid refrigerant from entering the section line. The eliminators are made from parallel plate bends into Z shape wire mesh screens on both plates and screens. An expansion valve maintains the level of the refrigerant. The tubes of the heat exchangers are usually both internally and externally enhanced to improve the heat transfer effectiveness. Now we will see the direct expansion evaporator. In this picture, you can see the refrigerant liquid goes inside the tube. Then the same refrigerant liquid converted into the gas going outside. Whereas the chilled water enter at the bottom, then leaving at the top. So it is just reverse to the what we have seen in the cell and tube evaporator. The direct expansion DX evaporator has the refrigerant inside the tube and the cooled fluid on the cell side. Larger DX evaporator have two separate refrigeration circuits that help return oil to the positive displacement compressor during the spark load. DX cooler have internally enhanced tubes to improve the heat transfer effectiveness. The tubes are supported on a series of polypropylene internal baffles which are used to direct the water flow in an up and down motion from one end of the tubes to the other. Water velocity do not exceed approximately 1.5 to 2.5 feet per second due to the pressure drop consideration. Condenser. This is equally important component in the chiller. In system involving the heat transfer. A condenser is a device or unit used to condense a gaseous substance into the liquid stage through cooling. In so doing, the latent heat is released by the substance and transferred to the surrounding environment. Now we can see here one side, this yellow, water is entering. Now the water get heated, taking the heat from the refrigerant and goes out. The other side you can see refrigerant is coming inside and loses the heat to the water. Then only condensing is happening. The gas refrigerant converted into the liquid refrigerant and moving to the expansion valve side. So condenser mainly does condensing. Expansion valve. The expansion valve removes the pressure from the liquid refrigerant to allow the expansion or change of state from a liquid to a vapor in the evaporator under a greatly reduced pressure. The liquid refrigerant is at its coldest as it leaves the expansion valve and enter the evaporator. You can see here two evaporator from condenser. Now P1 bulb pressure, P2 evaporator pressure and P3 spring pressure. So diaphragm moves down. Based on this diaphragm, automatically it controls. The expansion valve is a controlling device. Safety controls. Safety controls protect the unit under abnormal conditions. Safety control usually trip out the compressor motor and will require manual reset. Typical safety controls include high refrigerant pressure cutout, relief valves, low pressure section gas, lubrication, high temperature, motor, refrigerant, lubrications, low refrigerant temperature, time delay, low voltage, phase losses, phase reversal, high current, evaporator and condenser proof of water flow. Thank you for watching. Soon I will see you HVAC same module part 3. Please don't forget to subscribe our channel for regular update. If you have any query or comment, please email to me.